Okay, with number 1, we have to find the area of the parallelogram. So the formula for area of a parallelogram is base times height. So we have the length of the base, which is 15. They're both 15. So the base is 15. Okay, we just need the height. So we need to find this length right here. Okay, so turns out we have a right triangle embedded in the parallelogram. Okay, and it's a 30, 60, 90. Special right triangle. So we use our template n root 3 and 2n. Okay. We set up our equation. We know that 2n is equal to 6, okay, which means we divide by 2, that n is 3. We're looking for this side right here. So that means that our height would be 3 root 3. And this piece down here, if you wanted to find it, it's whatever n is, which is 3. Okay, so our height is 3 root 3. Okay, we just have to multiply these two together. We get 45 root 3 inches squared. That would be the area. Number 2, find the perimeter and area of the parallelogram. Well, this parallelogram is actually a square, so we know that all 4 sides are the same length. Okay, so they're all 4 going to be 2.4 centimeters. Okay, so all we have to do is multiply base times height for the area, so it'll be 2.4 times 2.4. That's going to be our area, so I'll work that out. Okay, so multiplying it out gives us 5.76 centimeters squared, but the directions say round to the nearest tenth, so it would actually be 5.8 centimeters squared would be the area. Well, we also have to find the perimeter, so it's important we read the directions carefully. So the perimeter, we're just going to add up all 4 sides, or same thing would be just to multiply 2.4 times, there's 4 sides, multiply 2.4 times 4. So let me go ahead and do that. Okay, multiplying 2.4 times 4 gives us 9.6 centimeters would be the perimeter. Okay, so we have 9.6 for perimeter, 5.8 for area. Okay, number 3, we're told that the area of a parallelogram is 50 meters squared. Okay, so we know that the base times the height would give us 50. So we know base times height gives us 50 meters squared. Well, what would happen to the area if the length, or if the base and height were doubled? Okay, so what would happen if they were twice as big? Well, what if the base were 2 times the base? What if the base were doubled and the height was also doubled? What would happen to the area? Well, I could simplify this and get 4b times h equals something. Well, I know that base times height is equal to 50. So 4 times 50 would give me 200 meters squared. If that doesn't really make sense to you, what you can do is just think of an example where the area of a parallelogram is 50. So let's just say the base were 10 and the height were 5. Okay, so we know that that area equals 50. Okay, well, let's double those. Okay, so just pretend like this is twice as big as the other one, or the base and the height are twice as big. So let's make this base 20 because it's twice as big, and the height twice as big as the other one, so that would be 10. So here the area would be 10 times 20, or 200 So you can see how it works if I actually knew what the base and height were. You would still get 200 meters squared. Alright, number 4 has 3 different problems in it. The first one is we have to draw a regular hexagon that has a perimeter of 36 kilometers. Okay, so I drew a picture of a hexagon. If the perimeter is 36 kilometers, then I know that each of the 6 sides would be 6 kilometers. Okay, we need to find the area. So area, we use the formula A equals 1/2 times the apothem times the perimeter. Okay, so 1/2 times, I don't know the apothem, but we do know the perimeter is 36. So now we need to find the apothem. Okay, so what we've been doing is understanding that you have 6 equilateral triangles in a regular hexagon. Okay, so if we look at this triangle right here, or half of this regular triangle, then we have a 30, 60, 90 triangle in there. So this would be 30, this would be 60. Okay, so this is what I have. Okay, and we know that this piece down here, it's not 6 because the whole length is 6, so it's only 3. Okay, think of your 30, 60, 90 template. We have 2n, n, and n root 3. Okay, well we know what n is. It's 3. So I can go up here and plug in 3 for n. So that side is 3 root 3, which means that my apothem is 3 root 3. So let me go over here and plug that in, 3 root 3, and we just need to multiply it. Okay, so I'm going to go ahead and cross cancel the 2 and the 36 because I know that half of 36 is 18. So now I just have to multiply 3 times 18, which gives me 54, and I still have my root 3. Okay, so it would be 54 root 3, what are we working with? Kilometers squared. If you needed that to be in decimal form, it would be 93.5 kilometers squared. Okay, part B, a square with apothem length of 8 inches. So I drew a square, drew the apothem at 8, and we have to find the area. So there's a couple ways you can do this. I'll use the area formula with apothem and perimeter. So the apothem is 8, and the perimeter we're not given, but we can figure it out. Okay, so if this length is 8, then this length we know is also 8, okay, which is the same length down here, so we know this is 16. Okay, and then each side, because it's a square, is 16. Okay, so we just have to multiply 16 times 4, or add 16 plus 16 plus 16 plus 16, and we get 64 for the perimeter. Okay, let's simplify this. So 2 will go into 8 4 times. Okay, now we just have to multiply 4 times 64, which is 256 inches squared. So that would be our area. Okay, so I went ahead and drew a regular hexagon with an apothem length of 30 centimeters. I wrote down the area formula and plugged in the apothem that I already had. Okay, now we're going to have to go ahead and draw a right triangle within the hexagon. Okay. This will help us find our missing side so that we can find the perimeter. So this right here is 30 degrees, 60 degrees, n root 3, and 2n. Okay, well I know that 30 equals n root 3. So 30 equals n root 3. Okay, let's go ahead and solve that for n. Divide by root 3, divide by root 3. N equals 30 divided by root 3. We need to rationalize the denominator, so multiply by root 3 over root 3. This gives us 30 root 3 over root 9, which is also just 3. So we end up with 10 root 3 as n. Okay. Well, n is down here, which means this piece is 10 root 3. Okay. But I want to know this length, so I'm going to have to double that. So 10 root 3 times 2 would give me 20 root 3. Okay, so each side is 20 root 3. Okay, so now we need the perimeter. So it would be, there's 6 sides, so we need to work out 20 root 3 times 6 will give me 120 root 3. So that is what I'm going to put up here for perimeter, 120 root 3. Okay, so now we need to go up here and simplify this. So I'm going to go ahead and reduce to n30, which will give me 15. So I just have to multiply 15 times 120 root 3. Okay, so this gives us 1800 root 3. And if you need it to be in decimal form, it would be 3,117.7 centimeters squared. Alright, number 5 is a little bit different. Now we know the area, we know the apothem, we want to know what is the length of one of the sides of this regular pentagon. So I drew the pentagon, we're looking for this. What is the length of one of the sides? Okay, so let's plug in what we have. We know the area is 145. Okay, 1/2. We know the apothem is 4. And if we can find P, the perimeter, then we can divide that by 5 and know the length of one of the sides. So let's simplify this. 145 equals half of 4 is 2, so it would be 2p, right? Because we can go like this. So it would be 2p. Divide both sides by 2. Okay, so p equals 72.5. Now remember, that's the perimeter, so we still need to divide that by 5 to get the length of one of the sides. So one of the sides would be 72.5 divided by the number of sides, which is 5. Okay, so that equals 14.5 inches. So each side is 14.5 inches. Number 6, find the area of the triangle. So we're using the formula for area of a triangle, which is 1/2 base times height. So 1/2, the base is here, 18 plus 8 is the whole length for the base, which is 26. And the height would be 12. Okay, so we just have to simplify that. So 2 goes into 26 13 times. Okay, so we just have to work out 13 times 12, which is 156 feet squared. Number 7, find the area of the square below. So formula for area of a square is base times height, or length times width, or side times side. Okay, now this time we're given the diagonal here. Okay, so we have to recognize that we actually have a 45, 45, 90 triangle in here. That'll help us find our missing base, which is going to also be the same length as our height. So let's draw our template for our 45, 45, 90 triangle. So 45, 45, 90. Okay, and it's n root 2. Okay, so we know that 17 root 2 is equal to n root 2. Well, that makes it kind of easy because 17 would have to equal n, or n would have to equal 17. But we could still solve it. 17 root 2 equals n root 2. Solve for n, so divide by root 2 on both sides. Well, it turns out those cancel out too, so 17 equals n. Okay, so our missing sides, n would have to be 17, so that makes these two sides 17. So we go back to our area formula. It's base times height, so 17 times 17 equals 289 units squared. All right, number 8, we have to find the area of this regular polygon. So we use our formula. A equals 1/2 apothem times perimeter. Okay, so 1/2 times apothem, which is 8. The perimeter, we need to count how many sides we have. 1, 2, 3, 4, 5, 6, 7. So it would be 5.6 times 7 would be the perimeter. So 5.6 times 7, 35, 39. So 39.2 would be our perimeter. 39.2. Okay, let's cross cancel. This turns to a 4, so we just need to work out 39.2 times 4, which equals 156.8 inches squared. Number 9, find the area of the triangle, round to the nearest tenth. Okay, so area of a triangle is 1/2 base times height. So let's plug in what we have. 1/2, the base is 7, and the height, we don't know. So we're going to have to use trig to figure this out. So 32 degrees is what we'll circle. X is the opposite side. 7 is our adjacent side. So we're going to be using tangent. Okay, so our trig equation we need to set up would be tangent of 32 degrees is equal to opposite, which is x, over adjacent, 7. Okay, cross multiply, and we get that 1x, or x, equals 7 times tangent of 32. Okay, well, we know that tangent of 32 degrees is 0.62, so it would be 7 times 0.62. Okay, this is going to give us x, okay, which is 4.34. That's our height, 4.34. So let's plug that in for height, 4.34. Okay, we need to work this out. If you want, you can reduce the 2 and the 7 and make the 7 3.5, but you don't have to. You can just divide your answer at the end. So we need to work out 7 times 4.34, which is 30.38. Divide that by 2, and we get 15.19, which we will round to 15.2. So that would be our area. Okay, number 10, we're finding the area of a trapezoid. So I wrote down the trapezoid formula for area. Okay, so we just need to plug in what we have. 1/2 the height would be here. Here, it's 10. Base 1 would be 16. Base 2 is 20. And we just need to simplify. So we can take half of 10, make that a little easier. So it's 5 times 16 plus 20 is 36. So we just need to work out 5 times 36, which gives us 180. We're working with yards, so yards squared. Number 11, we had to plot the 4 points and determine whether it's a square, a rectangle, or a parallelogram. Okay, so I plotted the 4 points, and it is a parallelogram. Okay, then we have to find the area. So area of a parallelogram is base times height. Okay, so you just have to, with these you just get to count. Okay, so the base, you just count the number of spaces or units, would be 1, 2, 3, 4, 5 units is our base. And height, count 1, 2, 3, 4, 5, also 5 units. Okay, and then just multiply them together, we get 25 units squared would be our area. All right, last one, number 12. Find the area of the figure. Okay, so we have a rhombus. So I wrote down the area formula for rhombus. It's diagonal 1 times diagonal 2 divided by 2 or times 1/2. So I will call this diagonal 1. So that'd be D1. Okay, so if you add both pieces, it would be 30 meters. So 1/2 times 30. Okay, now let's look at diagonal 2, which I don't have. So that's where we're going to need to do some work. Okay. So if you look, we actually have 4 right triangles, all the same size. Okay, let's look at this one. Okay, all I'm missing is this side of the right triangle, and if I have that, then I can find diagonal 2. So let's take a look at that right triangle. Okay, so this is 25, 15, and I need this one. I'll call it X. So let's use the Pythagorean theorem. So we'll have a squared, which we'll say a is 15. B squared, I don't know. And c squared would be 25, because it's our hypotenuse and it's across from the right angle. Okay, so 15 squared is 225. 25 squared is 625. Subtract 225 on both sides. We get b squared equals 400. Square root both sides. We get that b is 20. Okay. So what we found is this length right here is 20 meters, which means this is also 20 meters, which makes diagonal 2 40 meters. So we just need to plug that in over here, 40, and simplify, and we'll have the area. So let's cross cancel. 2 into 30 goes 15 times. So we just need to work out 15 times 40, okay, which turns out to be 600. 600 meters squared would be our area. All right, great job. You finished your review again. I hope you do good on your test tomorrow. Give you a couple stars. A few stars. All right.